Hi students, welcome back. Part 13, the unit 4, chemical bonding and molecular structure. Okay students, in the previous class we discussed about bond parameters of polarity of bond. Some of the molecules like is a type of molecules. See here, this is what AB type. Okay, so polarity is given. Some of the molecules will net dipole moment is 0. Some of the molecules were given so many values. So it's totally depend on polarities. Okay, it's a different electronegativity nature and the lone pair of electrons. Clear? So on that we are going to know about some different types of molecules, have their structures and dipole moment values. Here this is a type of molecule AB type. AB means A is as considered as a central atom. Okay, A is a central atom. Okay, so other B as a bonded atom. The central atom is bonding with B atom. Okay, see this is the several examples of AB type. HF, hydrogen fluoride. Okay, hydrogen chloride, hydrogen bromide, and H2, hydrogen molecule. Okay, so this is a dipole moment. Mu is a representation of dipole moment. Okay, so D is a Deboy. Okay, so the values for, see here, the HF molecule, this is a fluorine, chlorine, bromide. Already we discussed in the previous classes. They have fluorine having a high electronegative nature, so it will give the more values of dipole moment, 1.78. So D. Okay, and HCl is less than to compare of fluorine. This is 1.07, and bromine, hydrogen bromine 0.7838. But in the case of H2, so this is completely 0 because the H2, see here, H2, see they are having a non-polar, it's a non-polar molecule, compound. Okay, so this is non-polar, one of the compound, H2. It means they have similar electronegative. The HH, they have similar electronegative atoms who are sharing of electrons forming of covalent bond. So they have non-polar, one of the compound. See here, these are the polar. Polar will give values of dipole moment because of different electronegativity. So it gives 0. So these are all the structure of linear. The geometry or shape is linear. Okay. So now see the second type, AB2 type. Okay, A is a central atom. They have central atom is single atom. O, S, here of carbon. These are all the central atom. And B2 means combined atoms were, in the case of water, H, hydrogen atom. In the case here also H atom. Here oxygen atom is combined with the central atom of carbon. Okay, so now see this is the H2O. H2O is already discussed in the previous classes. H2O will give what? H, 1, 2, 3. This is what bent shape. Okay, it's a bent shape of structure. In this case, say hydrogen is less electronegative, oxygen is more electronegative. The move towards the more electronegative of oxygen atom. See here also same. So in that type of case, they have lone pair of electrons. They have lone pair of electron is going with the, in this case. So going with the direction. So it will be not a linear type of structure because presence of lone pair. So it will give 1.85 Deboy, the values of dipole moment. Either we conversion to get, already we discussed in the previous classes, watch the videos. Okay. So next is same case in the H2S also. Okay, H2S also same case. But here you see carbon dioxide. Carbon dioxide. See here, carbon is a central atom. Carbon is a central atom. So here oxygen, oxygen. Carbon 1, 2, 3, 4. 4 bond capacity. Oxygen carries 2 bond capacity. 1 and 2. Remaining are 1, 2, 3, 4. 1, 2, 3, 4, 5, 6. 1, 2, 3, 4, 5, 6. Okay. We only consider the central atom have lone pair of electrons. Here, the central atom of oxygen, lone pair of electron, this will give the values. But here, carbon dioxide, the central atom, there is no have any lone pair of electrons. In the case of corners who are having a lone pair of electrons, doesn't worry. Only the concentrate of central atoms, this does not have any lone pair of electrons, and moreover, it is a vector quantity, opposite direction or cancel each other. So here, say oxygen is more electronegative than compared to carbon. Carbon 2 moving towards the oxygen atom. Here also say carbon 2 move towards the more electronegative of oxygen atom. So they get sum of these two terms will net type of movement is 0 because cancel each other. So that's why they have the carbon dioxide or given the values is 0. It's net type of movement. Clear? Okay. I will be later in the theory of VSEPR theory. It is completely based on shape representation. We will be later on geometry or shape of the term. Okay. So now going to third one of the type AB3 type. AB3. See, A has a nitrogen, here also nitrogen. Here is cell BF3. Boron trifluoride. Say A has nitrogen, right? So B3 type NH3. Okay, NH3 ammonia. So see here, already we discussed the value is in the representation of Deboy. So 1.47, 0.1. In this case, this will give 0. Audience, these are all we discussed in the previous classes of videos. Okay. Nitrogen will have lone pair of electrons. So this is value is here. The nitrogen having a lone pair of electrons will give a values. The boron is there is have any lone pair of electron will be 0. Clear? Okay, next is last one. One more is AB4 type of beta chloroform. Okay, carbon tetrachloride. CH3. This will give 0 because of here. See carbon and bond with the 4 hydrogen. This is methane. Clear? So here is move towards the carbon atom because hydrogen is less electronegative than compared to carbon atom. So here is move towards like here, same as here. So all the hydrogen atoms, 4 corners of hydrogen atoms were moved towards the carbon atoms. So all those were cancelled out. Okay? Cancelled out to make net dipole moment is 0. Okay? So in this case, carbon tetrachloride, this is also same as like methane. All the cancel each other forming of this. But in this wise, they have not be cancelled each other to get the values is 1.08. Okay, students. So here all those will be the tetrahedral structure geometry. But in this case, these two are look like pyramid. See here, nitrogen. Say lone pair. This lone pair we can write like this. So this is look like, see here, this simple structure, the nitrogen, 3 having nitrogen atoms. This is the lone pair. The lone pair, this is look like what? This is what? Triangular. Look like this is a pyramid. Okay? This is a pyramidal structure. NH3 and NF3, both two are trigonal pyramid type of structure because of presence of lone pair. But in the case, this is planar, trigonal planar. We'll be discussing the next of hybridization. Okay? So these are the important of dipole moment, some of the types of molecules. Okay? So next is VSEPR theory. Okay? This is very important. Okay? VSEPR theory means valence, shell, electron, pair, repulsion theory. Okay? VSEPR. This means valence, shell, electron, pair, repulsion theory. Okay? The full form, or we call pronouns like VSEPR theory also. Okay? So here, this is will give geometry or shape of the any covalent molecules. Okay? We already know it. In the base of Lewis structure, the Lewis structure doesn't explain the shape of the molecules. Okay? Lewis structure alli ನಾವು ನೋಡ್ತಾ ಹೋದ್ವಿ. Lewis structure ಏನು ಹೇಳುತ್ತೆ? Shape ಅನ್ನು explain ಮಾಡೋದಿಲ್ಲ. It's a limitation. In the limitations ನಾವು observe ಮಾಡ್ತಾ ಹೋದ್ವಲ್ವಾ? So ಅಲ್ಲಿ ಏನು ಹೇಳ್ತಿದೆ? Lewis structure, the dot wise ನಾವು representation ಮಾಡಿ ತೋರಿಸ್ತೀವಲ್ವಾ? That was ಅದು shape ಅನ್ನು explain ಮಾಡೋದಿಲ್ಲ. So the help of this theory of VSEPR theory or VSEPR theory will explain about the definite shape of this any type of molecules. ಯಾವುದೇ ಮಾಲಿಕ್ಯೂಲ್ನ ಶೇಪ್ಗಳನ್ನು ಅಥವಾ ಜೊಮೆಟ್ರಿ ಯಾವ ಥರ ಇದೆ ಅದನ್ನು ಯಾವುದು ಎಕ್ಸ್ಪ್ಲೇನ್ ಮಾಡುತ್ತೆ ಇನ್ ದ ಬೇಸ್ಡ್ ಆನ್ VSEPR theory. Students, in 1940, the two scientists, Sidgwick and Powell, these two scientists were on the base of repulsive interaction of electron pairs in the valence shell of the atom. Okay? So Sidgwick and Powell, two scientists, in 1940 based on base ಮೇಲೆ repulsive interaction atoms bond pair ಅಥವಾ lone pair ಅವೆರಡರ ಮಧ್ಯೆ ಇರತಕ್ಕಂಥ force, the repulsive force base ಮೇಲೆ electron pairs, the valence shell electrons, outer shell of the electrons base ಮೇಲೆ explain ಮಾಡ್ತಾರೆ. Okay? It's very important for asking examination. It's very important. Okay? So later in 1957, Nihon and Gillespie, the further redefined, the two scientists were redefined the first statement of the VSEPR theory. Just ಮತ್ತೆ ಅದರಲ್ಲಿರ್ತಕ್ಕಂಥ ಸ್ವಲ್ಪ ಮಾಡಿಫೈಡ್ ಮಾಡ್ತಾರೆ. Modified means the lone pair of electrons only the concentrate of central atom. Central atom in a lone pair of base agi tagondu ನಾವು explain ಮಾಡಬೇಕು structure ಅಂತ Naipaul and Gillespie or exploit. The four scientists were contributed to give this VSEPR theory. Okay, the lone pair, any atom having a lone pair. The lone pair were presents or localized only the central atom. This is explained the scientist of Naipaul and Gillespie. Okay, so we'll see about some postulates of the VSEPR theory. Okay, let me discuss one by one. Okay, students, see, this is a main postulates of VSEPR theory. Okay, this is very important, asking for examination. Okay, so now going to discuss one by one. The first point is shape of molecule depend on number of valence shell electron pair around the central atom. You did consider any of the molecules. Okay, the molecule were presents valence shell electrons. For example, see here, say NH3, ammonia. Okay, so nitrogen is a central atom. So this is a bonded with 3 hydrogen, and the nitrogen valence electron is 5. In that 5 only 3 bonded are hydrogen jothe. Inna ulidirideenu 1 lone pair ಇದೆ. Say lone pair means 2 electrons. This is representation 2 dot 1 lone pair. 4 dot means 2 lone pair. Okay, so ಈ central atom ಎಷ್ಟು ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇರುತ್ತೋ ಅದನ್ನ ವೇಲೆನ್ಸ್ ಶೆಲ್ ಎಲೆಕ್ಟ್ರಾನ್ ಪೇರ್ ಅದನ್ನ ಡಿಪೆಂಡ್ ಮಾಡಿಕೊಂಡು ಸ್ಟ್ರಕ್ಚರ್ ಇದೆ. ಓನ್ಲಿ ಕನ್ಸಿಡರ್ ಸೆಂಟ್ರಲ್ ಆಟಮ್, ನಾಟ್ ಟು ಬಿ ಕಾರ್ನರ್ಸ್ ಆಫ್ ದಿ ಆಟಮ್ಸ್. ಓಕೆ, ದಿಸ್ ಈಸ್ ದ ಶೇಪ್ ಆಫ್ ದ ಮಾಲಿಕ್ಯೂಲ್ ಡಿಪೆಂಡ್ ಆನ್ ನಂಬರ್ ಆಫ್ ವೇಲೆನ್ಸ್ ಶೆಲ್ ಎಲೆಕ್ಟ್ರಾನ್ ಪೇರ್. ಕ್ಲಿಯರ್? ಓಕೆ, ಸೊ ನೆಕ್ಸ್ಟ್ ಈಸ್ pair of electrons in the valence shell repel one another. Okay, the valence shell alli enagtirutte, the atoms of electrons go repel each other. attatra bandange enagta irutte, repulsive force alli exhibit ಮಾಡುತ್ತೆ, repel ಮಾಡ್ತಾರೆ. How they form of pair of electron, a valence electron is repel. Okay, you like the person, so you have to be going with that. Okay, otherwise you have to keep distance. So this is also way of that they have to get the distance is maintaining the forming of what? The repulsive force is formed. This is repel each other. Okay, they sense electron cloud alli enagta irutte, the formation of negative charge. This means what? Negative charge alli appear agta hogutte. Okay, this is the second point. So next is pair of electrons tends to occupy any position occupy ಮಾಡ್ತದೆ in a space, means in a structure. So in that space is a minimized repulsion and maximum distance between them. So you did take one of the molecule of atom, so spherical atom. Okay, in this spherical atom the pair of electrons tends to occupy the position in a space. ಯಾವುದೋ ಒಂದು ಪೊಸಿಷನ್ ಆಕ್ಯುಪೈ ಮಾಡ್ಕೊಂತ ಇರುತ್ತೆ. Okay, this is occupy this position, just to be assume that. So the repulsive force ಇರುತ್ತೆ ಅಂತ ಹೇಳಿದ್ರೆ, repulsive force ಇದೆ ಅಂದ್ರೆ ಅದು ಅಟ್ರಾಕ್ಟ್ ಆಗೋಕ್ಕೆ ಇಷ್ಟಪಡಲ್ಲ. ಓಕೆ, ಸೊ ಅದೇನು ಮಾಡುತ್ತೆ, ಸ್ವಲ್ಪ repulsive force ಎಲ್ಲಿ ಕಡಿಮೆ ಇರುತ್ತೋ ಆ ಜಾಗದಲ್ಲಿ ಅದು ಅಟ್ರಾಕ್ಟ್ ಆಗುತ್ತೆ. ಬಟ್ ದಿಸ್ ಇಸ್ ಮಿನಿಮಮ್ ರಿಪಲ್ಷನ್. ಅಲ್ಲಿ ಏನಾಗ್ತದೆ, ಜಾಸ್ತಿ ರಿಪಲ್ಷನ್ ಇರಲ್ಲ, ಬಿಕಾಸ್ ಡಿಸ್ಟೆನ್ಸ್ ತುಂಬ ದೂರ ಇರುತ್ತೆ. ಸೊ ಆಲ್ರೆಡಿ ದಿಸ್ ಇಸ್ ಗಿವಿಂಗ್ ವೇಲೆನ್ಸ್ ಎಲೆಕ್ಟ್ರಾನ್ ಇಸ್ ರಿಪಲ್ಸಿವ್ ನೇಚರ್. ಎಲ್ಲಿ ಇರುತ್ತೋ ಕಡಿಮೆ ಡಿಸ್ಟೆನ್ಸ್ ಎಲ್ಲಿ ಬರುತ್ತೆ, ಜಾಸ್ತಿ ದೂರ ಹೋದಂಗೆ ಅಲ್ಲಿ ಏನಾಗುತ್ತೆ, ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್ ಕಡಿಮೆ ಆಗುತ್ತೆ. ತುಂಬ ಹತ್ರ ಇದ್ದರೆ ರಿಪಲ್ಸಿವ್ ಫೋರ್ಸ್ ಜಾಸ್ತಿ ಇರುತ್ತೆ. ಸೊ ದಿಸ್ ಇಸ್ ವೇ ದ ಪೊಸಿಷನ್ ಈಸ್ ಆಕ್ಯುಪೈಡ್. ದಿಸ್ ಇಸ್ ಅ minimum repulsion is present. But ಯಾವಾಗ minimum repulsion ಬರುತ್ತೆ, ಡಿಸ್ಟೆನ್ಸ್ ಜಾಸ್ತಿ ಇದ್ದಾಗ ಬರುತ್ತೆ ಅಲ್ವಾ? Yes, it's indicate what? they give maximum distance between them. Distance ದೂರ ಇರುತ್ತೆ ಅವಾಗ minimum repulsion ಇರುತ್ತೆ. Where it is pair of electrons tends to occupy the places. Okay, next fourth point. Valence shell takes as a sphere. Okay, valence shell means outermost of the shell. So complete. So for example, you take carbon. Carbon is 6 atomic number. 1s2, 2s2, 2p2. Okay. How much of valence electron is? This is K shell. It's complete. Okay. 4 valence electrons. This is a valence electrons. So now look at the point. Valence shell takes as a sphere. ಈಗ valence shell ನಾವೇನು ಮಾಡೋಣ sphere ಅಂತ ಅನ್ಕೊಳ್ಳೋಣ. Okay. So sphere with electron pair localized. Electron pair is located on the spherical surfaces. In the spherical surfaces, ಆ ಸರ್ಫೇಸಸ್ ಅಲ್ಲಿ ಮಾತ್ರ ಏನಾಗ್ತದೆ ಲೋಕಲೈಸ್ ಆಗ್ತದೆ. ಓಕೆ, ಸೊ type of the 4 atoms. So at maximum distance from one another, already I told it, they have repulsive nature. The repulsive nature means they have distance is more. So ನೀವೇನು ಮಾಡಬೇಕು, ವೇಲೆನ್ಸ್ ಶೆಲ್ ಅನ್ನು ಸ್ಪಿಯರ್ ಅಂತ ಅನ್ಕೊಳ್ಳಿ, ಒಂದು ಬಾಲ್ ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ಕೊಳ್ಳಿ. ಅದರಲ್ಲಿ so have a surfaces ಅಲ್ಲಿ, not in the inner side. ಇಲ್ಲೆಲ್ಲೂ ಅವೇನಾಗ್ತದೆ ಲೊಕೇಟ್ ಆಗಲ್ಲ, ಓನ್ಲಿ ದ ಸರ್ಫೇಸಸ್ ಅಲ್ಲಿ ಆಗ್ತದೆ. The surface of the sphere is located, it will give maximum distance. Okay, ಏನಾಗ್ತದೆ maximum distance from one another. In the sphere ಎಲ್ಲಿ ಬೇಕಾದ್ರೂ ಇರ್ಬೋದಲ್ವಾ, ಈ ಸ್ಪಿಯರ್ ಅಲ್ಲಿ ಏನಾಗ್ತದೆ, the valence shell of electron is attracted in the more distance, so they make one another having a large distance. This is will happen the repulsion in this repulsion in that one more point is there, lone pair. The lone pair is more repulsion nature than compared to lone pair with bond pair of electrons. It is more than the bond pair and bond pair. Okay, it's a very important thing here. The lone pair and lone pair between the is very repulsive nature then compared to the lone pair bond pair. The bond pairಗಳ ಮಧ್ಯೆ repulsive nature ತುಂಬಾ ಕಡಿಮೆ ಇರುತ್ತೆ. ಫಾರ್ ಎಕ್ಸಾಂಪಲ್ ಸಿ ಹಿಯರ್, so one of the example of ammonia is say lone pair, right? So what I tell you, the bond pair, this is a bond pair, it's a bond, this is also bond pair, the repulsion distance is very small, but in the lone pair bond pair the distance is very large. This is large. In the case of lone pair bond pair, lone pair, the repulsion is very much repulsive nature than compared to these two. Clear? Okay. So next point is multiple bond is treated. Multiple bond is a multiple bond, single bond with double bond and triple bond. This is called as multiple bond. The multiple bond is treated as a single electron pair. ಅದನ್ನ ನಾವು ಏನು ಕರೀತೀವಿ, single electron pair ಅಂತ ಕನ್ಸಿಡರ್ ಮಾಡ್ತೀವಿ. But two or more electron pair of the multiple bond. Electron pair ಇದ್ಬಿಟ್ಟು multiple bonds ಇದೆ. Say more than two or more than two electron pairs of the multiple bond are called simple super pairs. Okay, this is we call as simple super pairs. And one more important point is two or more resonance structure. Already we discussed in the resonance structure of bond parameter. More than Any molecule will give more than two structure, we call it as resonance structure. Two or more than two resonance structure can represent a molecule. Yavadaru resonance structure kodtaganta molecule iddaga molecules we represented the VSPR theory, the VSEPR theory applicable for the molecule. Anta molecule structure anna represent ಮಾಡೋಕ್ಕೆ ನಾವು VSPR theory na ನಾವು applicable ಮಾಡ್ತೀವಿ. Okay, these are the main postulates of VSPR theory. Okay, so the next class we are going to discuss on the VSPR theory based of some of the molecules of shapes or geometry. Okay, thank you.